So after discussing this, see this what we'll be covering today. First of all, I will tell you what is AI. I will ask you what do you mean by it and what it is and what are the different types. Okay, what are these terms? What is artificial intelligence? What is machine learning? What is deep learning? What is generative AI? Okay, and where all are they being used in cybersecurity? Right? We will demystify all these things here. Okay, and then I will tell you that how the attackers are weaponizing AI in cybersecurity and how we can defend against them. Okay, so for this, I will show you one security workflow that we have, your threat detection workflow. So you can see here we can detect your network based attacks also. We can detect uh, email spam emails, phishing emails, that these workflow I will show you, and how you can create your end to end. So I'll give you a demonstration right from data collection till our deployment part. Okay, and I will show you that how I have deployed. See, I will show you how we can create the model first. So the development aspect, what all things are done in the development, and then what all things are done when we deploy this model. Okay, so initially I will show you a normal workflow. Then later on, I will tell you if we don't consider the security aspects while developing and deploying. So then what are the risks that you have if you don't consider that? And then how you can incorporate the security aspects while the model development and model deployment. So let's begin with our, like, we need to know what these different terms are: machine learning, deep learning, AI, data science, natural language processing. All these different terms are there. Okay. So now when you hear this term AI, artificial intelligence, you can, in agentic AI, the security is major concern over here when it comes to agentic AI. Right, because you can use it, you can use agentic AI in your security workflow also, but it is a thing that it reduces your security stance. But recently there have been some developments when it comes to agentic AI also, that how you can securely deploy agentic AI also. Okay, Ankur says learning and response, yes. So your learning based systems, okay, we have another term here, learn and response. So learning from new data, yes, and maybe responding to the incidents that are coming so that you can reduce the time, the incident response time. Human like processing that we have, it can think like we have that. So see, when when we talk about this human like processing, so we had AI systems beforehand also, like from 2010 onwards. So if you see your, you must have seen the spam detector in your any email client that you're using. So if you're using Outlook or Gmail, you must have seen there is a spam folder there where your messages are going inside that. Okay, though initially it was a bit rule based, but your learning based or your AI based spam detectors, they have been using for quite some time now, more than 10-15 years you have been using this AI. So you had AI based applications earlier also, but as I mentioned, this breakthrough event that we had here, watershed event in your November end, like 31st November 2020, 30th November 2022, when your chat GPT, it came out. So that people found it quite intriguing, because they thought that okay, this is, we have, the humans have created something that can understand language also. It can understand, like you have TTS also, text to speech also in that, so it can talk back to you. It can take in your voice input, so it can listen to you, it can speak. So in one way it has like the human related sense organs, right? And now that, like, it has the image processing capability also, it can create images also, so you can give it visual information also, it can generate visual information. So it's like giving a model some ears, eyes, right, and your mouth to talk. Okay, so you have people started relating with them. Like when they started talking to them, they felt like they were talking to a human being, right? So though it is another thing that if you give in continuous prompts again and again, then it tends to hallucinate. There is a issue with context window. There are these kind of issues, but still, this human-like processing, it intrigues us. And yeah, AI systems, they have this human-like processing. Okay, what else we see here? Yes, yes, Shimpa. Intelligence created artificially, yes, like machines behaving like humans, yes, human-like processing, what we have here. And actually an intelligence based on data fed into an AI model. So that was about to be my next question over here. That see, you have this human-like processing, okay, and we have covered this part also. Some of you have mentioned this problem-solving skills that you have over here, okay, can give prompt faster than computers, having thinking capability, okay, learn from past incidents, create new inputs accordingly. Yes, yes, Manasa. Okay, it learns from past incidents, and the past incidents are there in the form of a data set that is there in that data. Okay, so you have human like processing, you have that thinking ability, though you can, there are many ways to define thinking, right? But still, as you see, this problem solving skills, it can analyze your complex situations and it can make intelligent decisions. So when you see these two things, problem solving and human like processing, so it is able to do this because your models, your AI models, they have the ability to recognize the patterns. Okay, just like how our human brains, like we have our sense organs, we have eyes, ears, nose, mouth, tongue, right? All these things we have. So what the real world data is coming in for us also, okay, and then our brain, like those sense organs are taking all those signals to our brain. The brain is where the main processing is happening, and we are generating meaning out of that. Okay, so we are also, in one way you can consider that we are very advanced machines, okay, though that is debatable. You can say like what is artificial, what is real, okay, that is one thing. But see, you can also see like humans are taking in sensory inputs, and then making some sense, our brain is making sense of the patterns and then coming to some conclusion. Okay, so the similar process is happening in AI systems also, right? It is able to recognize the patterns, and once it has recognized patterns, so say if you're training your model to, like let's take cybersecurity use cases only, that you want to train your model for identifying malicious attacks, your network based malicious attacks, say like uh, sniffing based attacks or DOS attacks that are there. Okay, so what we do, so let me ask you this pattern recognition, where will these AI models perform the pattern recognition? So we can say yes, yes. So these are specific examples. So in Splunk also we can have all those forwarders, we can take all those logs, your network logs that are coming in, we can take that. Perfect, perfect, Mohit. Yes, you have structured and unstructured data. So generally you'll see that your data is in unstructured form, and then you need to do your data pre-processing steps to convert your unstructured data to structured data. Yes, Ahmed. Yes, perfect. Old data sets, right? So what happens? You have your data sets. Okay. So say you have created a data set. This is a Excel sheet, and you have various columns over here above. Different column names are there, and let's just say you're training a model to identify malicious links. Okay, phishing links that are there. So we can have different features we will take out, that what a phishing link actually looks like. Okay, what that phishing links look like. So you will have features like, if a very long URL length is used, like very long URL for hiding the fact that the domain names might be different, right? This can be one of the feature. Whether only IP addresses are used in place of domain name, whether it is redirecting you, right? So all these things can be written in that column here as that features. And in the end, you will have a label here, and here you can label. So you will have your patterns. Okay, some numbers will be there here, right? Inside this data set, some numbers will be there, and you can correspond them to either 1 or 0. So if the label is 1, it means that this is representing a malicious data. Okay, and if the label here is 0, you can say that it is your normal data only. Okay, so what we do, we will feed this data set to our algorithm, and the computation will happen, and then it will learn that, okay, these are the patterns, that what your one looks like what malicious data looks like. Then it will say, okay, these are the patterns what your zero looks like, your normal data. So next time when that real world data will come in, okay, so say your incoming data is there, okay, your model will see the features of this data. Okay, it will see the pattern in them, and then it will try to predict 1 or 0. Okay, and if it has predicted 1, it means malicious data, then it will raise the alerts, right? Depending on whatever tool that you're integrating your model with, whether you have integrated with a EDR solution, your endpoint detection response, or whether you're integrating it with a SIM tool. So that way you'll be able to perform the monitoring also later on. So this, that the data that is coming in, there we do that pattern recognition, and that gives the AI systems the problem solving thinking capabilities and your human like processing capabilities, just because of this pattern recognition over here. Okay, and one more thing, say your historical data that is there, you'll have two kinds of data when you're dealing with artificial intelligence models, with AI models, right? When you're dealing with the training of AI models, so you have your historical data, right? Some data that may be representing past network attacks. Okay, so this historical data is called your batch data, and you can have new incoming data also. Okay, your new data will be called as streaming data. Okay, so you have your batch data and you have your streaming data. When you're training your model, right, we are developing the model for the first time, you will train it on this historical data, the incoming batch data. Okay, see, if I ask you about traditional rule based system, maybe you have some signature based detection or rule based detection in your anti malwares or IDS. Okay, so let's just say this is a IDS, and there are two ways to detect. One is your, you have the signature based and behavior based, right? So you can call it signature, you can call it rules also, signature or rules based detection. Then what you do, you can use AI models, right? Be it machine learning and deep learning. Okay, so you have a signature and rule based detection and AI based detection, in which you can either do the anomaly detection or behavioral analysis. Okay, so these, your traditional ones are rule based, and this one is learning based. Okay, that's why you can see this point here, learning and adaptation for our AI systems. So tell me, when you compare this behavioral based one, right? When you're comparing the learning based one and signature based one, what are the differences? Yes, yes, Ahmad, perfect, perfect. So and yes, Sumit, yes, we combine and use them. Okay, so see, if you are dependent only on signature or rule based detection, even if your incoming network traffic, like a attack traffic that is there, even if slight changes there, even if slight changes there in that pattern, this signature or rule based approach will not be able to detect it. Okay, because it is dependent on those static rules. If this kind of attack happens, then raise the alert, all these things. Okay, so it, whatever patterns are there, it is determined. Okay, and even if some slight change in that pattern is there, then it won't be able to detect. Okay, so this is the disadvantage that we have here. But here, this, since here we are analyzing the anomalies in that behavior, so even if slight changes there in that attack, we will be able to detect it. Okay, but if, when, since we have introduced AI, it's not that like we have forgotten the old systems. No, that is not how it is happening. We are using AI as a augmentation tool to the ones that are already existing. So we are using, so what will happen in our IDS first? First, the rule based detection will only happen. If it is unable to find something, then only this your anomaly based detection or your AI based detection will take place in that IDS. Okay. And now, so the good thing about this AI is that it can detect new patterns also. It can, if there are slight variations, it can flag that as an anomaly. Okay. And if we want to improve the model, if we want to improve the functioning of the model, so in the end, our model is always dependent on our data. For AI, right? We say that data science is very important. See, that's why we say that data is the new oil, or the new gold or the new oil, right? Because uh, AI is, of course, you are aware that AI is not just being used in cybersecurity, is just being used in almost each and every field that we have. Okay, so you need the perfect representative data, right? You need good enough data. You need lots and lots of data. The better your data is, the better your model will be. Okay. So in our case, like for developing cybersecurity controls, you need lots of, say, network related information, past network data, uh, the logs related data, your emails related data for detecting phishing emails. Okay. So what happens, see, you'll have your batch data set, that is the data set for this historical data, that you will train your model. And then once you have deployed your model, you will, you want to retrain your data again and again. Okay, that's why we call it a machine learning cycle, life cycle. I will introduce that machine learning life cycle to you later on also in our later slides. So here what is happening, your entire data set, whatever new data is coming in, that is being updated into your existing data set. Okay, so you're updating, your data set is being updated with this new data or streaming data, what we call it, and then the retraining of your model happens. Okay, that is the reason we say that these systems, AI systems, learn from experience and adapt to new inputs. Okay, so these are these main features, that how you can differentiate a AI system from other system, that this pattern recognition capability of AI systems give them the ability to problem solve and human like processing, and they have the ability to learn and adapt. Okay, so this goes with AI, right? What all things you need when it comes to AI. Now, just one more thing here. Can you tell me the three building blocks of creating a AI model? If you want a AI model, if this is the outcome that you need, there are three building blocks that we have here. We discussed one of them, like what is the AI models looking patterns in? Where do they find the patterns in? When I asked you, that was one of the building block. Yes, yes, our data is one of the building block that we have. What else? Since the slide, we have limited space here, I'll be making use of this one note for explanations. You have your data, and see, when I talked about pattern recognition, when I spoke about pattern recognition, right? So, what are the thing that helps in recognizing the patterns in this data? That is your algorithm. Okay, so algorithms finds pattern in this data using the compute power. Okay, if you are training traditional machine learning models, the CPUs will be enough. If you have lots of data, you will require GPUs also over there. You will require parallel processing capabilities for your large language models. You know, you're using GPUs for processing. Okay, so these three things that you see here, data, compute, and algorithms, they are the building blocks for making your AI models. Okay, so these three you can say are the building blocks for developing these AI models, right? And now when we see here, we'll see different types. So of course, we'll quickly just see this. See, these they're use cases. What you see here, these are the AI use cases. Okay, so many people like they tend to think that okay, AI is automation only. No, automation is a use case of AI. And before you had AI, then also automation was possible. You could automate things with by shell scripting, bash scripting. Okay, you could write down a Python code for automating things. Okay, there are rule based automation tools like Wazoo. Okay, for automating the response that we have. But the thing is, by combining the existing rule based tools with the AI models that we are developing, right, we can increase the speed of automation that we have here with AI. Okay, so you can see some of the use case that may not be related to cybersecurity also, because AI that you're using it everywhere. Okay, now see automation. And if you're going with rule based, you know, you're working reactively. Okay, if this is happening, then do this. Okay, if this attack happens, then only will respond. But AI, it also gives us the capability to predict the attacks. Okay, so we can train our models for various indicators of compromises that are there. So right when if someone is doing the scanning only on us, network scanning, so we can see that we can come to know, we can some incoming network, there will be anomalies in that. So we won't even have to wait for the attacker to start his attack, right from when he's even scanning the network, when he's trying to collect the information or doing the recon phase of ethical hacking that we have. Okay, so there we can detect it quite early. Okay, so that's why we have predictive analysis and automation with AI. And also we have the classification and regression tasks. Okay, so regression means when you're predicting a value. regression predicts a value, and classification, what you have, it predicts a class. See, you have these building blocks, okay? Data, compute, algorithm. So I'll give you a very simple example so that you will be able to understand that how, like, what do we mean by models in the first place? Okay, these AI models, what are them? So that for that reason, I will tell you a very simple machine learning model. Okay, see, before we come to other use cases of this anomaly detection behavior analysis, I'll show you. See, when we come to AI learning types, you'll see machine learning, deep learning, generative AI. Okay, so what are these? When you're making this AI system, when you're designing a AI system, you can see this AI models that are created using data, compute, and algorithm. So based on the algorithm we are using, we will get the AI model. Okay, if we are using a machine learning algorithm, we will get a ML model, machine learning model. If we are using a deep learning algorithm, we will get a deep learning model. Okay, and so on. If we are using something related to generative AI, so we will get a Gen AI model. So when you're looking at these AI models over here, so as I told you, you can classify it based on the algorithms you're using. So you can have machine learning models, you can have deep learning models, and you can have your generative AI models. Okay, so various algorithms you will find under them. So if you see your machine learning models, you'll see, if you see the algorithms used. So within machine learning algorithms, you can find your logistic regression, linear regression algorithms, okay, decision trees, random forest, support vector machines, okay, naive bayes, k nearest neighbors. So these are some of your algorithms for supervised learning. And then I'll tell you this also, that what do we mean by supervised and unsupervised learning. Then you have some algorithms for unsupervised learning also. So you have lots of clustering k-means, clustering algorithms over here. So mostly your machine learning models are statistical and probabilistic in nature. So what we are doing, as you know here, this AI, artificial intelligence, it combines, it is very multidisciplinary in nature, mathematics, cognitive science, statistics, data science. Okay. So here, what you're doing, see, since we are trying to create some models, AI models that can predict the things for us based on, like, it will see the historical data, and it will learn the patterns, and then it will see the incoming data, what data we have, and based on that data, it will try to predict that whether it is a malicious attack, or whether if you want to predict the sales of an organization, the future sales, or the customer churn rate, right? That how often that customers will leave your service that are there. And so you can use it in a wide variety of applications. So for that, the most basic approach is that we have this statistical and probabilistic models over here. So how, I'll just give you an example of how AI is, this machine learning works here. Just imagine any data set that is there. So data set are computers, it can understand binary, right? So we can convert that data into binary. So for computers it is okay, but for our representation we can represent our data in the form of a graph. Okay, so your most simple model that I'll tell you so that you can relate in this is just as simple as the equation of line that we have. Okay, so y can be any dependent variable, right? So generally we say that f of x, right, a function like that, and it is dependent on x, right, if this x is changing. Okay, then we give some formula over here. So what you have here, you are changing that value of x. X is the independent variable. So you have your equation of line here, mx plus c, y is equal to mx plus c. So m here is this slope that you have, okay, slope of your line. So if value of m is very high, it will be something like this. If value of m is very low, it will be something like this. C is the intercept. So if c is 0, it will begin, line will begin from the origin. If c is in positive value, it will begin like this. If c is negative, it will begin like this, and so on. Okay, so what happens, say you have collected your data, and any data, it can be represented in that graph. Okay, so say your data points of the data that you're collecting are lying down somewhere, something like this, okay, in that graph. So what happens when we see data compute algorithm? Okay, this is our data, this is our algorithm, the linear regression algorithm, and compute, like it will study the computing, like our processor will study this particular data, it will find the patterns using this particular algorithm over here. Okay, so what, since this is just a equal, and see, you might find this example too oversimplified. Yes, because it is, because this is the most simple use case, you can say, your most simple algorithm for AI, for machine learning. Okay, so what will happen, it will try, your model will try, because now it has the data and it has the compute power for identifying the pattern in this data using this algorithm. So what will happen, it will change this value of m and c, right, this model on its own, right, the humans are not doing it, the model will do this. It will change the value of m and c such that the line that is created, right, because this is the equation of a straight line, so the line that will be created should include maximum amount of data points. Okay, and at least, like, if they are not including all, other ones should be more nearby to it. Okay, so this will be the prediction line. This is the prediction line that will be created. And say if you have new incoming data, okay, you have new incoming data, and if it lies down somewhere over here, okay, so then that way, so your y value is here this side, so you'll see this. And okay, this is the new value of y, this is the new value that we want to predict. Okay, so say this is something around 4000 over here. Okay, so value of y what we are predicting is 4000. Okay, so simple as that. Like, so this is your regression model. In regression model, you are predicting a value. Okay, similarly you will have a classification model also. Okay, so just linear regression is your, linear regression was your regression model. And then say you have logistic regression, so here instead of equation of line you will use a sigmoid function. So that way a function like this will be created, and here you can, some data points that will be lying this side, some data points will be lying this side, and this line, this is the decision boundary, this is the decision boundary that we have. have, and the data points say that are this side, say they belong to malicious data, and this is your normal network traffic. Okay, so if you are identifying a class, right? See, here we are not predicting a value. Here we are predicting value. So say if you are predicting, if you have been given parameter features such as the house, that place location where the house is there, or the size of your house, okay, and based on this you want to predict what will be the price of your house. Okay, so here we are predicting a value, so that is regression. And again, in cybersecurity use case, if you want to see, so like you do that quantitative threat analysis, risk assessment, quantitative risk assessment. So there you want to identify the risk, the quantitative risk, if this risk is realized, so what will be the loss for us. Okay, so there also you're predicting a value, so there you can use regression algorithms. And if you want to classify, right, spam or not spam, malicious not malicious, okay, so for that you can use these classification algorithms. Okay, so you have your classification and regression, you have seen automation, you have seen predictive analysis, and our AI applications, because see, it can recognize pattern over there, so you can recognize anomaly also. So what you can do, you can create a baseline for your normal data. Okay, then if anything that deviates from this baseline, right, above this or is above the baseline, so that you can categorize it as an anomaly. Okay, and then you have behavior analysis also. So when in cybersecurity, you're talking about uh, zero trust security, where you need to continuously verify, right, the user, the behavior, also the device behavior. Okay, so here we have one very important things, that is our UEBA, user and entity behavior analytics. So what you're doing there, you can do things like, you can, how is the access pattern of that user. Okay, things such as keystroke detection model. So you know that if someone performs phishing attacks and gains access to your password or your credentials, username, password. So what we can do, we can train that a model that will accept password only if it is there. Say if it is your password, so it should be the typing pattern should be similar to you, right? So that we will train the model initially, it will identify typing pattern, and then if someone gets access to your password, and if they are not typing in your typing style, so then they won't be able to log in. Okay, so that is possible due to this behavior analytics only, right? So in zero trust security, in UEBA, right, this AI plays a very crucial role, and we have behavior analysis for that. Then, so we spoke about machine learning, deep learning over here. So here I'll tell you this supervised learning and unsupervised learning. So here in supervised learning, what you're doing, you're dealing with a labeled data set. You have labels, and here in unsupervised learning, we have no labels. So I'll show you two example data sets, uh, for one for supervised, one for unsupervised. Just give me a moment. So this is the data set. Okay, so if you see this here, you can see I spoke about the features, right? Our data sets have many features. So those features you can write it down here. This is structured data that we have here. So as I told you that these are data, this is a data set that represents the features of phishing links or normal links. Okay, normal link or phishing link. So in this case, what would have been our unstructured data? What would have been the unstructured data? See, when we talk about our, yeah, so labeling is one part that we perform here. So without the labels also we can have structured data. So this, you can see this last column that we have here, result, that is indicating labels over here, are labels 1 or -1. So -1 is signifying phishing link, -1 is signifying normal over here, and 1 is signifying phishing link. Okay, so you can have a structured data set without your labels also. In this case, the unstructured data will be your collection of the phishing links when you're collecting the phishing links. Okay, so just your phishing links in proper text format in your original link form only. Okay, so there when you see this machine learning life cycle or the AI model building life cycle that you see, I'll just show it to you. You can you see this entire machine learning or deep learning, whatever model you're building. It will depend on that. So you know that you need to define your problem first of all. Okay, that what are you doing? What are you creating a model for? What is your use case over here? Are we creating a problem to detect phishing emails, or the text-based analysis we are doing, or the link analysis we are doing, or are we doing attachment analysis? Are we uh, detecting for malwares in that phishing text, or are we detecting network-based attacks? Are we detecting phishing, your sniffing based attacks or DOS based attacks? Okay, so all those things will be there here, and including your threat modeling part. When you're uh, incorporating security in every phase, then you will also include threat modeling over here, that your entire attack surface analysis you will do, where all attacks are possible from, how you can safeguard against them in your further steps, what you need to do, right? Everything will be defined here itself. Okay, then comes our data engineering phase. Okay, so we have our two broad phase, data engineering and model engineering. Okay, so here your first step in data engineering is to your data collection part. You need to obtain your data, or data collection you can say. Okay, so we will take this use case only, this particular data set that I'm showing you. This is our structured data. This data, what we will get it after we do the data pre-processing. Okay, see, it is either called as data scrubbing your data, or it is called as pre-processing your data. So what we are doing here, we initially have unstructured data. We do perform this data pre-processing and convert it into a structured data set. Okay, from unstructured you will get a structured one. Right, so that is the idea behind pre-processing, the data pre-processing phase that we have. Then what we do, you need to explore, you need to validate your data and extract relevant features. So you call this step as feature. So I'll just label these main steps that we have here: data pre-processing, and here we have this feature extraction, or feature engineering. So see here, for this feature extraction step you require good domain level knowledge. Okay, so if you are creating models, AI models for using them as cybersecurity controls, so you need to know how your cybersecurity attacks work, what are the patterns of a attack, how you can help your models identify these patterns. Okay, so that is why we are doing feature engineering. So as I said, domain level expertise. If someone is creating a model for predicting the sales over there, so they need to have good knowledge when it comes to that, like how the sales is functioning, right? Then you need to have domain level knowledge for performing this feature extraction. See what I mean by that? This thing, this is feature extraction. So the person who has developed this research paper over here and created this model, Like there is a research paper behind this particular data set that we have. So in that, what they've done, can you see these features over here? Having IP address, if the URL length is greater than 54, whether any URL shortening services is used, because you know that the domain names may mismatch. Okay, so for that, they may either increase the URL length so that the end user or the target who is there, he doesn't sees that particular link. Okay, doesn't sees this particular pattern in that link. Or what they may do, because the domain name is not matching, so they can use the URL shorteners. So you must have seen some URL like this bit.ly, right? Tiny URL like this other service, so you can make use of this URL shortening services. So what you have here, you can, these things what you're extracting, see this, your existing data is there, you're converting them, right? And then you're extracting these features, right? Whether they have double slash, whether they're redirecting. So these are all the features of a phishing email. So that is the fact that they're creating new columns in your data for these features. This is called as feature extraction. Okay, and then we are writing down 1 or 0 here for yes and no, and we are giving the labels. So what will happen then when you see this next phase? Once you have your feature extracted and pre-processed data, this is the data set that will be used as an input for training your model. Then again, all these things will happen. What we have covered over here, this one, that how your data, compute, and algorithm they are working, right, to build a AI model. Okay, so you know you have your data over here, which is being used as an input for training. Okay, so we will select the, according to our use case, we will select which model we need, and then we will train our model. Okay, and see, while training, what we will do, if you see this data set over here, while training, if it is supervised learning, see, we are discussing supervised learning right now. These are the features. So your algorithm, it studies these features. See, this is one data point. So this is what you see in the row 2. This is the information for one email, one phishing link. What you see in row 3 is your information for another phishing link, or right, this is information for another phishing link, third on. So you can see there are these many data points. So if you see a data set, you'll see the number of data points, number of rows that we have here are around 11,056. So if you remember the first one, there are 11,055 links in our data set. Okay, so initially unstructured data, the link is just in link, the data is just in the link form as it is raw data that we have, and this is our finally structured and feature engineered data where we have even removed those required features, right? So what we are doing while fitting it, we will take 80% of our data, right? Not 100%. We will take 80% of our data, and we will use this 80% of our data set as an 80% of these data points that you see here. So not around all 11,000, around 8,500. These many data points will be used for testing the training the model. So while training, we will provide our, in our code, we will do the coding such that these features we will give the model all these features, and we will give them our, sorry, the algorithm, we will give it the labels also, that okay, this is what a -1 looks like, this is what a 1 looks like, so this is what your normal link looks like, this is the pattern in your malicious link. Okay, so all this it studies. Okay, so by the end of your training, it has recognized what a -1 looks like and what a 1 looks like. Okay, and these are your labels. See, these are the labels we are telling our model that these are the features, right? So we are training our model in one way with this data set. Okay, we are telling it that these are the patterns of what a -1 looks like, these are the patterns of what a 1 looks like, right? So this is what is happening when we are doing the training phase. The model is understanding what a 1 looks like. See, a model doesn't has the see this AI model what you're creating, it doesn't has the concept of DOS attack or normal attack, phishing links, normal. It just understands numbers, right? 1 0 over there. Okay. So what does we are teaching it to predict a one or minus one over here. Okay. So in training phase, we are giving it both the features also and the labels also. And in the testing phase, when you come to this testing phase over here, testing the model, what you're doing, you will provide the model only with these features, only with the features. We won't give them the labels. The labels will be predicted by the model, right? It will see this feature. Okay, this feature, this looks something like a minus one. So let me give you 20% of your data. This process will be happening, right? Where we will be giving only the features and it has to predict the labels. Then finally you will evaluate your model, that how accurate your model is, how it is working. So what we'll do, we have our original labels and we have our predicted labels what we got by testing the modules, the model. So you can compare the predicted labels with the original labels, and that way you'll get the accuracy, you will get the reading of your false positives, false negatives, true positive, true negatives, all these things you can fine tune your model until you're satisfied with it. Once you're satisfied with the model accuracy and the evaluation metrics, then you can finally deploy it. Okay, so there we have all our MLOps part where you can deploy your model also, and you need to continuously monitor it because it is continuously learning from new data also, right? It is continuously learning from new data, learning and adaptation is taking place, right? So for that reason, we have this MLOps here where you can monitor this and see when we are giving in new data, when streaming data is coming, then of course these steps will be repeated again. That's why we are calling it a life cycle over here. Okay, so this is our entire life cycle that we have for developing these AI models. So you know the development part over here, and you've seen this supervised learning also, that how it is working with labels. So second, this one. In supervised learning, you have seen this, we have this labels over here. In unsupervised learning, what will happen, we won't give the labels, the machine learning model that is there itself, it will perform the clustering algorithms and it will cluster say your normal traffic in one place. I'm just giving a graphical representation so that it is easier to visualize. Okay, and in other place it will cluster your say normal traffic related data. Okay, so if you have generic use cases over here, you can go with unsupervised learning. Okay, but if you want specific use cases, if you want to train your model, say for your own data, custom data that you're using, okay, if you're not using the in already existing data sets over there, if you're doing something from scratch from your own use case, then we prefer supervised learning. Otherwise, we can go with unsupervised learning. So if you see this Splunk ML solutions in your Splunk or in your Elk stack also, they have inbuilt unsupervised learning in them. So we can use the unsupervised learning there. And if we want to customize, if we want to create our own custom models and integrate with that, so then we mostly use the supervised learning for that. Okay, semi-supervised learning is you have your data set, okay, and you have some labels, right? Say you have 10,000 data points, okay, 1 2 and so on till 10,000. Okay, you will label only some of them, right? Manually you will label some of them. It will study the pattern, okay, what a 1 looks like, what a 0 looks like, and so on, and then rest of the data will be filled by the model itself. So you can say remaining data set, okay, remaining data set filled on its own by model. Okay, so we have seen supervised, unsupervised, and semi-supervised. This also you have reinforcement learning, and it is used a lot in robotics. Okay, and you must have seen lots of this game playing AIs are also there. So in 1997, that Gary Kasparov, that number one chess player at that time, was beaten by this IBM Deep Blue. Okay, and even in 2017, that one game was there, Go. So that model was AlphaGo. It beat that world champion in Go, and Go has way more variables, permutation, combinations than chess. Okay, so beating a human in Go at that time was quite a big achievement for these AI models. So what is happening here? It is reinforcing, as in one activity is happening multiple times. So it is, if idea is to play the game over there, so it is playing multiple thousands of games are played. Okay, or if in robotics, if you want the robot to walk in a straight line or pick up some goods and keep uh, deliver it in some other place, so that is the particular task. So that part is being done multiple times. So what you have here, you have a reward function in reinforcement learning. Reward function is there, and you have this concept of your reward points and punishment points. Okay, so if the result is not optimum, if we are getting a wrong result, then this punishment points are given. So this reward function's value is lowered over here, right? In the end, the goal is to reach to a optimum level, a high level of your reward function. Okay, so that will only be possible if the model will collect more and more reward points. So if it is doing something wrong and if it gets a punishment function, then it knows that okay, it has to not do a task in this particular way, it will find some other workaround. Okay, and if it is getting this reward points, then it will say okay, it is doing something right, so it will do a similar kind of thing only. It will try and keep trying to improve itself based on that. That's why if you have so many iterations, if you have played 5,000, if that model has played 5,000 games with itself, then it tends to become very good, right? In that way. Okay, so just like how some parents, they may teach or they like, not everyone is following this parenting approach of giving rewards and punishment, but still, like how parents, they might teach their child, this is just one way like that. So here you can just consider that the AI model is just a child whom you're teaching it based on this rewards and punishment, and that is what is happening in this reinforcement learning. Okay, so you've seen this machine learning over here, and this deep learning is also there. So you can see this part. See, this ML models we were discussing. I told you examples of lots of ML models, and I told you they are statistical and probabilistic in nature. So this naive Bayes, you must have learned this in mathematics. Your Bayes uh, theorem that is there, right? So you have just have a modified Bayes theorem over here, where you're using that same formula only. Okay, you're just modifying it a bit. What is there in your Bayes theorem, and you're trying to predict the things, because prediction means things related to probability. Okay, so your models are using statistics. This here example, it is example of a statistical model only. In this linear regression that we have, same goes for your logistic regression, where you're trying to separate different classes over here. Okay, so now deep learning means when you're using the artificial neural networks. Okay, so deep learning, this you can say here, uses artificial neural networks. So what it is, we are inspired. So what is the basic building block of the human brain that we have? There are some nerve cells, right? What are those nerve cells called? You call them as, what are the nerve cells called? Neurons, right? So you can create, so the network of artificial neurons, that is our artificial neural networks. Okay, so here, based on whatever algorithms we are using, so we can use the multi-layer perceptron also. It is also called as feed forward neural networks. Then you have the convolutional neural network, and you have recurrent neural network. Okay, so your multi-layer perceptrons or feed forward neural networks that are there, they are built like this. You have your different, each circle that you see here is an artificial neuron, and there will be one input layer. So your data will go into the input layer, right? Based on how many features we have, we'll have that many artificial neurons. And then you have the hidden layers. So in deep learning, we have at least two hidden layers. Okay, and then we will have a output layer. So say if you want to predict a particular class, 1 or 0 here, so we'll get that output. So just like your neurons are there, they have input dendrites, they have for output, they have axons over there, right? And then they have your cell body where that processing is taking place. So here also it is just inspired by the nerve cells, your neurons, and we are creating these artificial neural networks with that. Okay, so if we are giving our AI models the eyes, okay, the ability to image, to perform the image recognition, video analysis, okay, medical imaging. So then we can use this convolutional neural networks. Okay, that convolution function takes place here. You have that ability to process images over here. Okay, if you have lots of time series data, see this time series prediction. So it means when your data, if you have if you're collecting historical network data and it is spanning for say 3 4 days or weeks together, data worth weeks you have. Okay, so there when your prediction is happening for a long period of time, you can make use of this recurrent neural networks. Okay, then finally here, so see, we have seen machine learning models, we have seen deep learning models, and we have our generative AI models also. Okay, so in generative AI models, you will see things such as variational autoencoders, you will see generative adversarial networks. Okay, your small language models and large language models also come in this. Small language models and LLMs, large language models like your OpenAI, ChatGPT, or Anthropic's Cloud or Grok that we have. Okay, so this you have here. Then you can have your diffusion models also for your image generation that are there. You have different types of Gen AI models, generative AI models that we have. Okay, so you can see now the entire difference, like how, where does AI stand, where does machine learning stand, where does deep learning stand over here. Okay, so say if you are creating this, if we'll see it through a flow chart, a Venn diagram over here. So say you have your all AI systems. Okay, AI is a separate field, and data science is also a field, and data science merges with artificial intelligence, because you have seen in that when we were seeing the data engineering and model engineering phase. So we know that all the phase that was coming in your data engineering, that will include the field of study of your data science also. That's why we are saying data science is overlapping with artificial intelligence. Then within AI also we have different types of models, right? So you have your machine learning, which are the statistical and probabilistic models, and within that you have deep learning, which uses artificial neural networks, right? And then we have the generative AI models. Gen AI, you can say it is a further subset over here, right, within deep learning itself. Okay, machine learning, deep learning, generative AI, artificial intelligence, data science. So I hope you get the difference between all these terms now. Okay, so generative AI models, we are saying generative AI because it is used to generate something. Okay, it is either generating an image, some text, some i- video. Okay, so what you're doing here, it is a more complex model. Like you're using lots of different neural networks over here. Okay, so if we take the example of this generative adversarial network, okay, if we take example of this generative adversarial network, you can see this here also. We are covering this, your generative adversarial network. It has two neural networks. This generative adversarial network. Okay, one is your generator, and another neural network that we have here is a discriminator. So see, where you're using this generative adversarial network, if we want to create synthetic data, video generation, art creation, image generation, and see, since you're generating video image, you can even say things such as deep fakes over here, deep fakes, voice clones, right? So your attackers are making use of this generative AI, this generative adversarial networks for creating deep fakes and voice clone also. Okay, you can use generative adversarial networks for creating malware samples that actually look benign. Okay, so these are all the cyber offensive related things that you can do using this generative AI. Okay, so how it is working, you will have your real world samples over here. So you can say this real data is there here. What happens? This generator tries to create this real data. Okay, so discriminator is getting both the output of generator and the real data. Okay, so what will happen between this generator and discriminator, between these two neural networks? A adversarial game will take place. Okay, where this generator will try to fool the discriminator that okay, I am creating real samples. Okay, and discriminator will try to catch the generator. Okay, so if this, what happens? You have a feedback. The discriminator gives a feedback to the generator. So what will happen if this discriminator has caught the generator? So it will tell that okay, I have caught you. So that will happen via a loss function over there of some value will be there. In that way, it will tell the generator that okay, the generated data is not good enough, right? It is not even close to this real data. Okay, so this will happen in one learning cycle. So one learning cycle is also called as one epoch. Okay, so like that there will be multiple epochs, 1,000 epoch, 5,000 epochs, or you can say 5,000 learning cycles. In each and every learning cycle, the performance of this generator, it will become better and better, right? Then there will come a point where the data that is generated will be almost like so real, like almost as like similar to the real data, that the discriminator won't be able to find the differences in that. Okay, so that is how your synthetic data is created, how your deepfakes are created, how your malwares can also be created. Okay, so then we have this, and finally, you must have heard another term that is called your natural language processing. So, natural language processing is also a completely different field that we have here. Okay, you cannot say that it is within AI, within data science, right? Natural language processing is another field. So this is just like giving the ability to our models to read, right, text related data. So now if we are dealing with text related data, so in cybersecurity where all we have text data, so you can say your use case is there in phishing, your NLP, your network logs also, I can say. And say like if you want to summarize your threat intel reports. Okay, so we can make use of NLP in our pipeline over there, right? So what we'll do, this phases that you see over here, when we want to transform our data in our data engineering phase. Okay, so there we can simply use natural language processing. If we are dealing with text related data, we can use natural language processing over there, right? That will make our job quite easy. Okay, the development of the models will become quite easy if we are using natural language processing when dealing with text related data. Okay, if we don't have text related data, then the traditional machine learning and deep learning approaches are well and good. Okay, so now we have seen we have our complete big picture over here, right? We just have to see where all we are using it from your cyber offense, defense, and how you can secure these systems, right? So this big picture part of the things is clear. Let me just clarify one more thing over here. So, okay, so now you can see all these different models. We have discussed about machine learning, we have discussed about deep learning, we have discussed about generative AI models also. Okay, so the thing is, it's not just about LLMs. So in cybersecurity use cases, tell me now. See, you have this big picture over here. Use this as a reference. Use this as a reference and try to tell me that these things, the things you have related to machine learning and deep learning, uh, where can these be used in cybersecurity? And when it comes to your generative AI, so your specifically your large language models, where are these used in cybersecurity? Where are LLMs used in cybersecurity? And where are your machine learning and deep learning models used in cybersecurity? Yes, Donatus says in network security. Okay, network security for what? Which particular model? Is it our the traditional machine learning, deep learning one, or the newer large language models which are used in what? When we are talking about AI-based security controls, be it in your network security, be it in endpoint security, see, you can look at defense in depth. Are you aware about this term? Defense in depth? Yes, multi-layer security. Okay, we are not just securing one layer over here. We have different things. So when you look at your enterprise network, okay, entire enterprise network, how it is built, you will have say your perimeter will be there. Okay, where you will apply physical security. So you know the difference between cyber security and information security, right? If in cyber security, if we include the physical security aspect also, so that will be your information security. So information security you can say is the superset, cyber security is its subset. So you have your perimeter security or your physical, this physical security. So things such as gates, locks, securing your devices, physically securing them. Okay, bollards. Yes, zero trust, you can combine it with defense in depth, Dinesh. Yes, and zero trust is used using all this privileged access management, your UEBA techniques, what we have seen. Okay, for behavioral analysis, incorporating AI, continuous verification of your devices and the users. Okay, so you can see you have your entire physical, so you'll put gates, fences, everything for that physical security, CCTVs also, right? Then you have your network perimeter, right, where you can put security controls such as firewalls, IDS, IPS. Okay, because you have say your external net network is there, right? Your internet from where you're getting the internet connection that is coming in, then you can put firewalls over here. Say then you have put a intrusion prevention system. uh, Routers will be there, switches will be there, firewall will convert it into different interfaces. It will form a DMZ also over here. Okay, then say you'll have your internal network over here. So this is your external network here, this is your internal network. Okay, and internal network you'll have various devices. Okay, you can have end user devices, you can have the servers, right? You can have other printers, right? So for these devices also, you need, these devices are called endpoint, so you need to secure them also, you need to secure your endpoints. So you can have your, for securing endpoints, you can have anti malwares, right? You can have the EDR solutions. Okay, endpoint detection and response, extended detection response, right? EDR XDR solutions for endpoint security. Okay, then you have application security, your secure applications that you're developing, they should be secure coding, they should follow the principles of secure coding. Okay, and then finally this data security, because we need to secure all our entire data, so proper cryptography techniques for that, encryption, hashing. Okay, and behind everything, you need to create the policies, right? Which your GRC teams can create, like your upper management can create, right? Whether you're complying with if a cybersecurity framework is there, this cybersecurity framework. So are you complying with them? Okay, are you comply? So if it is credit card company there, so are you complying by PCI DSS? Okay, if it is a uh, medical data, if you're storing, so are you complying by HIPAA? Okay, and then your day-to-day operations are there, so you can say your SOC teams over here. Okay, so this is our entire net enterprise structure, you can see, and how we are applying security controls over here. So when we talk about AI powered security, when we are implementing things over here, so you're implementing security controls at your network level, at the endpoint level, okay, and for your data security also. So mostly the heaviest applications you'll find here in your network security and endpoint security and email security also. So email security can be a part of your AppSec, right? So you're securing a particular application over there, okay. And once you have created your models, be it machine learning models, be it deep learning models, say you have created machine learning model for network security, so you can integrate it with the IDS, firewall, IPS. Okay, if you have created something for detecting malware, so you can integrate that model with machine learning models with your EDR or XDR solutions that are there. Okay, so you can see just like this defense in depth it is there. You can incorporate AI in each and every layer. You can incorporate these AI security controls. Okay, so when you're talking about these AI security controls, the things, the models that you see over here, your machine learning models, deep learning models, even till your VAEs and generative adversarial networks, till here, these are the ones that are actually used as security controls. Okay, so I'll just put this over here. These models are mostly used as security controls and for automating the things, for increasing the response times. Okay, these are our AI based security controls. All these models, what we are developed based on whatever. So it'll depend, because if you want to train model for detecting the network based attacks, so we will have to use the appropriate data set accordingly. So these data algorithms, this machine learning life cycle, for that it will be different. For creating a model for detecting phishing attacks, for that your machine learning life cycle will be and different, right? So don't forget the data engineering and the model engineering phase that we have. Okay, then of course we have our ML ops phase where we will deploy and monitor the model. Okay, so these are mostly used as security controls. And when it comes to these LLMs over here, okay, though it is coming under generative AI only, but these you're mostly using as a productivity tool. You can summarize things for yourself. Okay, you can summarize the threat reports, provided you have deployed it securely. Okay, say if you are dealing with sensitive data, then you need to make sure that these models are deployed locally, right? You cannot just put it in Chat GPT, what is hosted in someone else's computer, or what we call cloud. Okay, you should not use those models over there, right? We should use only those those models that we have complete control over, and the data that is being hosted, it is completely under our control, right? Provided you're working with secure some sensitive data in that case. Okay, so you can use, to summarize, you can use these large language models to create exploits. Okay, you can ask it to create detection rules. You can use them to code, write down code, right, as a coding assistant also. So you can see these LLMs are mostly for making our job faster, right? Doing the things quickly. That is why we are using LLMs. But when it comes to using AI as security controls, then we still have to work with the machine learning and deep learning models. That's why machine learning and deep learning is also very important. It's not just about LLMs. Okay. And so, say if you are a developer over there, or if you are a security engineer, when you talk about your SOC teams, you have your L1, those who are mostly monitoring, L2, the incident responders, L3, mostly working in digital forensics, right? So you have different levels over there. Then you have your same engineer or SOC engineer also. So nowadays, the SOC engineers who are being hired, they need to have this particular knowledge that how you can develop these models. And the good thing is, so I will show you a code snippet also that how these models are being developed, and I will also show you a code where you can use frameworks such as AutoML, right? We'll use frameworks such as AutoML to even automate this process of model creation, right? We just have to change some parameters, tweak some parameters, know what we are doing, what model we are building. Are we building regression model, classification model, right? Just those parameters we have to give, and that way we can do this part over here, right? We can automate it. Okay, so you have our complete big picture, hope, through these things now. Yeah. So we've seen various types. We've seen the machine learning life cycle also. So we'll just see some offense, cyber offense, and cyber defense use cases that we have here. So you can say that it is your AI, offensive AI is that artificial intelligence where that attackers they enhance, automate, and scale that cyber attacks. Okay. So why, see, since we are using this offensive AI capabilities, it has given that attackers to make such kind of malwares that are more stealthier, right? They can evade your rule based ideas that are there, because you can create so many different types of attacks. You can slightly vary that pattern, so your uh, rule based detectors that are there, they won't be able to detect these attacks. Okay. If you see this, it uses, you can use machine learning, natural language processing. You can create deepfakes, as I mentioned, that deepfakes you're creating using generative adversarial networks, right? And then you can bypass the security controls also. Okay. And you can automate the attacks, and the reconnaissance that is done, you can do it the reconnaissance in such a way that you can gather such information that you can create hyper personalized uh, phishing emails. Okay, like earlier, like you must have seen that phishing emails, if you're trying to create, then it creates lots of grammatical errors over there. But now you can use any AI tool for that matter. So if I just show a simple example to you, uh, what I'll do here, I'll use this OpenAI's ChatGPT itself, and I will ask it to create a phishing email. So I have not tried this in GPT-5 over here. Let's see if it works. Yeah. So what it does, if you try it sometimes, so what happens, because I've already given it a context over here. So I just gave a simple prompt, create a phishing email, right? I didn't even try something, a prompt injection technique. So what happens, because I've given a system prompt from here inside. So uh, what it does, it bypasses that security restrictions over here. So what happens, like if you do it for the first time, it it won't generate this phishing email. So you can give it more context also. I have not given it more context. So see, it has made a realistic phishing email, okay, with proper subject also. And so I can mention also that create a phishing email asking the user to uh, change the password of the Facebook ID, otherwise it will be logged, something like that. Okay, so you can see we detect suspicious login activity from your Instagram account on this device and this so and so date. For your protection, your account has been temporarily logged. So here you can create this, and you can restore. To restore full access, you will have to log into that particular link over here. So I can also tell it this way, like give me space for adding a link. Okay, so this way you have this way, so you can insert a malicious link over here, right? So you can say earlier whatever features were there, grammatical error, all these things. So now you can make it, you can do the reconnaissance activity to create a hyper personalized mail. So instead of just dear user, you can write down the name also. You can find out whatever activities are of interest for that particular person, right? So for those things, like what attackers make you see, this is phishing, this is social engineering. I'll show you reconnaissance also. Okay, show you recon. And by the way, this, if you do it direct, it won't work for you. There will be safeguards, right? In my case, it is working for me because I have given a system prompt earlier that my uh, students are quite inquisitive, so they might end up clicking on a phishing link. So I want this phishing link, phishing email, to be as realistic as possible. Okay, so using this same prompt, I can create a code for your, say, performing DOS attacks also, or any malware related attacks, right? So I'll just show you. So in the time being, I'll show you the reconnaissance activities also, that how you can make use of AI. So when you do this, so first of all, you have your entire Google hacking database also, right? Where you can find a list of exploits over here. There are predefined dorks also. Okay, so you can use in Google search, you have some operators like this, like site. So if you want to narrow down your search to a particular site over there, or if you're finding information about some person. So right now I won't given your name. I'll just use my name over here. So I won't give the full name. So what I'll do, see, I'll just search for this my name. So you can see how many we are getting around, more than 20 million results we are getting over here, right? More than 2 million results we are getting, right? So around 20 lakh, you can say, right? So if I just use this simple operator over here in URL, so from 20 lakh, you can see only 45,000 results now, right? So that way you can narrow down a person, you can find out information about a person. Okay, so attackers are doing, they're weaponizing these things using tools like this dark GPT. Okay, so if you, what you can do, even if you, like, attackers, they don't have that much technical knowledge to generate a Google Doc. What they can do, if they have forgotten the operators of, they don't know in what way to use, in which combination to use a particular Google Doc, they can simply ask what they want, right? What they want to narrow down your search for. Yes, yes. In the name, if you can give the double quotes also, that way it will narrow down even more. Okay, so if you are using multiple names, if you have a name and surname over there, then you can put them under double quotes that way, so that if you want them to appear together in your search, right? So here you can write down a Google Doc key, like how that generate a Google Doc that will help me narrow down my searches on so and so name, that you can give over here. Okay, or you can give the list of all unauthenticated IP cameras. Okay, so these are some of the Google Docs that we have got here. Either you can try this or you can try this. See, this or symbol is there in between, right? So you can either try this or that, right? So in URL view.html, so we try this. So you can see here what we are getting. We have got whatever we wanted, right? We wanted to search that. We have got an exact list. So it has told us that. So if someone doesn't knows that they have to search this, right? If they are just with plain text, they have got the technical response also of that how they can search for unauthenticated IP cameras. Okay, and this you can know that how attackers can make use of this when it comes to reconnaissance over here. With this for reconnaissance activities, they can use these unauthenticated IP cameras that we have. Right, so it is loading here the things. Right, so you can see that this IP cameras related information we've got. There are some places that you can even control these cameras. You can change the settings. You can even move them in some cases. Okay, so like this, attackers can find out almost anything. Okay, and then so this is one of the thing. So malwares also, right? They can create polymorphic malwares that continuously change, that evade defenses. Okay, you can use tools like this worm gpt. Okay, and many of these tools are available in the dark web for these attackers to purchase. Okay, and so right, generally those attackers, they were very uh, technically aware, that they knew the things technically. But now if someone is not even that tech savvy, even he can, someone doesn't knows how to write down the code from scratch, they can generate their own code for creating polymorphic malwares using tools such as this worm gpt that we have, right? We have tools like fraud gpt also, right? All this is giving the attackers so much power. Okay, so automated reconnaissance you can do, AI generated phishing, these generative adversarial networks which can be used for voice cloning, deep fakes. Okay, there was a case study here where recently one CFO of organization, someone used the voice clone of that particular CFO and targeted an employee, telling them to wire so and so amount into a particular account. Okay, and that being the voice of a CFO, the employee didn't even question, because he was thinking that it is a order from the senior itself. Okay, so then they will do it, right? So we've seen that how AI can be weaponized in all this way. This polymorphic malwares, evasive malwares, right? Using generative adversarial networks, you can create such malicious inputs that evade your even your machine learning or deep learning based malware detectors. It can evade them. Okay, so you can bypass these machine learning defenses with adversarial inputs. I will tell you what these are. Okay, so you've seen this evolving threat. Why traditional cybersecurity is not enough? Because your attacks, because we have seen how these attackers, they are weaponizing. They, because of it is so easy, that technical knowledge also required is not that much. So that's why they can quickly create it. It is faster. They can create attacks that are stealthier, that your security controls won't be able to detect them. Okay, and all these things, you can see your attack surface is also expanding, right? IoT you're using, bring your own devices, so you have more attack surface, so your attacker, it is more easier for the attacker. Okay, and this AI, it has given the ability to the attackers to conduct multi-vector attack campaigns. Multi-vector as in they use different attack modes, right? Not just dependent on one attack. So they may perform DOS attack also, then they may perform web-based attacks, right? DOS attacks, if they're doing, they will conduct 3 4 different types of DOS attacks together. That's why we're calling it multi-vector. Okay, they have multiple paths of uh, entering your systems. Okay, so you can see this limitations for your traditional based approach, that of course that we have already seen that it is signature based detection, manual threat triage you need to do, right? But in this way we can auto with AI we can automate it. In traditional ones you don't have behavioral analysis, right? All your tools, they are quite contained, that they work separately, the integration is not there, they're siloed. Okay, alert fatigue, so if there are manual alerts if you want to generate, so that can lead to like your analyst can be overwhelmed because of that. Okay, AI, it increases your visibility. Traditionally you don't have that much visibility over here because you can automate your monitoring part also. Automate monitoring. Okay, and then this here you have perimeter centric mindset. Okay, just look at the firewalls, IDS, IPS, they are working. If they are not detecting, then you're stuck. Okay, but here with AI you can follow the zero trust mindset also, right? Not just perimeter based approach. You are not just applying security controls at the perimeter, you're applying security controls everywhere throughout your entire organization, like even continuously verifying the user behavior and user device behavior over here. Okay, so all that is possible. So by this defensive AI, what we are doing under defensive AI. Okay, so defensive AI is when we are applying your machine learning or deep learning models to detect anomaly, the anomaly detection. Okay, that can help to identify intrusions. You can correlate various various threat signals. So when you're talking about that, see, like if you have your a detective is there. Okay, he is piecing together multiple small clues to solve some case. Okay, so your correlation rules also work that way. So what you can do, you can use AI to enhance your rules. So what you can do, you can use AI to enhance rule based detection, right? It enhances these correlation rules that are there. Okay, so like if the AI is there, it can isolate a compromised server automatically, and it can flag it for that later those SOC analysts to review it. Okay, and then you can respond automatically. So I'll there is a slide where I'll show you that in which use cases you can completely automate the response, and in which case you can make it semi autonomous. Okay, so right, so you can build that models. So as I told you, you can monitor logs also, network traffic, user behavior. Okay, you can integrate them into your sim tools, your IDS and IPS, right? And automate the detection and enrichment of security events. And you can apply, see, this is very important, adversarial training. I will tell you what it means once we come to that ML SecOps part. Okay, so this is our automated response, that how you can block your whatever IP that you want to see. When we were discussing that advantages of AI, so we saw that automation over there. We saw predictive analytics. So how it is done? See, automation means if you have integrated your model, your machine learning or deep learning model is there. Okay, and it has detected some anomaly. Okay, and it has seen that there is some IP associated with that particular packet which is anomalous. So what you can do, you can create rules to block this. So that is how you're incorporating automation here, because it is blocking these IPs. Okay, if it has found out some malicious logs coming from a endpoint, a device, so it can you can set up rules to even isolate this endpoint from the network. Okay, it can trigger incident response playbook also. Right. So how is it possible? This part we have discussed, because it learns from historical attack patterns and it creates a behavioral baseline. Right. It uses the decision logic that we train that ML models to assess the risk in real time. Okay. And you can map all the threats to the predefined incident response playbook. I hope you're aware about these incident response playbooks, that you have playbooks for incident response that tells you that okay, if this particular incident happens, then how will you respond to that. Okay, so then you can execute automated actions also by integrating API with that scripts, right? So that predictive analytics in cybersecurity, see various things that we have over here, right? When we are utilizing machine learning, deep learning to analyze historical and even real time data. Historical was batch, real time was streaming data. Okay, you can future threat, you can forecast, you can look at system vulnerabilities. Okay, so you can predict what insider threat detection you can do. So for insider threat detection, what, see what I told you, prediction is happening what, it is looking at patterns in data, right? We have discussed this, patterns in data, based on that it is predicting. Okay, so for your inside thread, what all patterns you can see? Sudden change in pattern change, excess pattern change. Okay, privilege abuse. Similarly, for the things where you're integrating ML or AI models in endpoint for your EDR, right? For endpoint risk or for forecasting, right? So devices likely to be compromised. Next, that it sees web application attack prediction predicts bot-driven abuse or DDoS patterns. Okay, patch management prioritization, which unpatched vulnerabilities are most exploitable. Phishing risk analysis also you can do this way, right? So all that, it sees that patterns, that what your phishing data looks like, phishing email looks like, or phishing link looks like, what a normal link looks like, right? And how it does that, we have already seen through this workflow, that what is built in your ML workflow that is there, right? And then we have over here that what all options, that how you can integrate them in your organization. See, you have two choices. You can use three choices, I would say. You can use proprietary tools. The you can use your you can develop your own custom tools. You can use open source tools, or you can combine all of them. Okay, so if you're going for proprietary solutions, if you're looking at them, you have say you're working on Microsoft stack or Google stack. Okay, so if you're working in Google, just taking an example of Google. So for your model development deployment part, you can use Vertex AI. You can use Sentinel. Sorry, Sentinel is Microsoft. We have Chronicle here in Google. You can use Chronicle, and for your productivity related tasks, right? For summarization, all these things. Okay, for helping you with day-to-day activities, for like if you want to ask them some questions, you can integrate a LLM also. And in case of Google, it will be a Gemini. Okay, so this combination is for Google stack. If you're looking at Microsoft stack, so you can use your Defender XDR plus Copilot, right? Plus the Sentinel also. Okay, if you're using Cisco related, if see, you can use Cisco AI Defense also. But the thing with these proprietary tools are that your entire infrastructure, it is dependent on that. So if you're using Cisco AI Defense, your all the routers, switches, and all those components that are there, they need to be on Cisco. They need to use Cisco's infrastructure only, Cisco devices. So we are limited to that, and we have less customization possible over here. Though if you go for Vertex AI, we can customize it a lot. So when it comes to customization, this Vertex AI is very awesome. But these other tools, Microsoft ones, we have limited customization over there. So if we want more visibility or control over our data, and if we are more security minded, then we can make use of this, or we can even go for the custom tools, right? Custom solutions. So what we can do, we can create our own machine learning or deep learning model, and then integrate this model, say within Splunk, or your Elk stack. Right, and then there are some AI powered your network detection response and behavioral platforms also, like this Vectra AI, Dark Trace that we have. Okay, so these are some ways. And see, when you're creating this tools in the entire, say, you have Cisco AI Defense, just an example I'm giving you. This is a tool that is already created. Okay, this one custom tools. So say if you want to work for any product based organization like Palo Alto or say Cisco only that are developing their own security tools. So if you have the knowledge of this developing these custom tools, these ML models, and how you can integrate them, right, and then how you can use your open source LLMs, you can use your open source LLMs. That way you can create the entire thing that was there using this Microsoft Defender XDR Copilot, right? Copilot is giving you LLM capabilities, right? And your Sentinel, right, which is acting as a same tool or a SOAR tool, it is, right? Security automation, security orchestration and automation response. Okay, so that entire tool, using this you can create your own custom solutions over here, your own model, you can integrate that, and you can even use a LLM there, right? You can build a RAG pipeline, retrieval augmented generation, wherein you can give in your own data sources, right? So this is how all this data it can be created over here. So when you have your uh, tools, once you have created a model and once you want to automate it, so you have a choice. Though with AI you can fully automate also, but when do, in case of AI, when do we prefer human in the loop? Okay, so if you have high risk or sensitive see, if you have high risk actions, okay, which are quite sensitive, then you can put a human in the loop. Say if it is a low risk and high confidence action, means you're confident about your result over there, that you're completely confident that your AI model is giving you the right result over there. Okay, so AI can directly execute response actions without delay over here. So say if you have some with your suricata, which is IDS, where we have integrated machine learning, and that is detected some command and control attack over there. Okay, so what you can do, you can use tools such as Shuffle, which will automatically block the IP, right? And it will give the alert also. So you can see the second, the response here is in milliseconds, right? And we have completely automated it, right? Because here we are just blocking the IP, and you know that particular this IP, it is present in some IPDB, abuse IPDB list over there. Okay, so in that case, you can automate this quickly. But if you have some action here where it is high risk, so say if you want to block a user account, so that can be a high risk action also, because a false positive may be generated. Okay, because what if you end up blocking a critical account in that way? Right. So that's why it will just raise a alert, and then you will have human in the loop, the analyst who is there. He will view that alert and he will verify that whether this account can be blocked or not, and then only he will block it. So though you can see the speed here, you're not, the response is not in milliseconds, but still the alert what you have got, that is in millisecond level. Okay, and then the y- human in the loop, whoever is there, you can, the analyst can take the decision based on that. So here, based on our use cases, you can go for human in the loop or fully autonomous response. Okay, now finally we have our security aspects, that how you can incorporate security into your entire machine learning life cycle. Okay, so what you're doing in each and every step, what you have seen our model engine, data engineering phases, what were there, data pre-processing, feature engineering, model training, model deployment. So there we can incorporate the safe security steps and all. So you see this, when you look at that, how this, because you're incorporating this, this is important over here. Attackers can poison the models, they can extract the models, and they can evade the models. Okay, so with MLSec ops, you're adding observability, uh, explainable AI, you're reducing the bias. So if you see these things, if you see all the risks that we have of using AI in cybersecurity, and securing. So if when we are using AI as a security control, so that itself is a new attack surface. So what risk that introduces? So these are the main risks. Okay, a system can be biased. It can be biased. Uh, your decisions, you may not never come to know that how the AI model is coming up to that decision over there, right? So to avoid that, we use explainability frameworks like Lime and Sharp that are there. Okay, for fairness, we can use tools like your IBM Fairness 360, Google's What If tool is there. Okay, so here you're reducing the bias. So your data set should be well represented. And see, it is not just about your your societal bias, right? It is also, you can say it can be network related also. So what if your data set, it is focusing on only one protocol, or maybe focusing on only one network attack, right? That way it will be biased only for this particular network attack. It will overfit the data for this, right? So it is not just from societal point of view, it is from your cybersecurity point of view also. Bias, your models can be biased. Okay. C2 beacon is like C2 stands for command and control. Command and control. So like when you have your entire botnet, bots are your compromised systems. So any system can be compromised, and then the attacker can use those system, say for sending in malicious inputs or for doing a DDoS attack. Okay, so this particular network of botnet, this command and control botnet, that you can call it as a C2 beacon. Okay. So now this is explainability. You need to know this explainable AI, XAI. This terms also we see here. Like you must have heard this term, responsible AI. Okay, the AI compliance, AI governance, how you can secure these AI systems. So w- the main pillars of responsible AI, that what makes a AI system responsible, are these: that it should show the property of fairness, it should be explainable. Okay, so for this we can use frameworks like this Lime and Sharp, right? I will show you this model just quickly. Um, give me a moment. Though we have passed our timing, but we will have to take 10 minutes more because I have some practicals to show you. First, I will show you one practical here, just that how you can conduct the see all those machine learning life cycle steps that are there. I will show it this one first. You can see this attack for conducting this. For this is a model that I have created for detecting DOS attacks. Okay, even your novel DOS attacks, the new kind of DOS attacks that are there. Okay, so this particular DOS attack, my IDS was able to detect the basic HPing 3 based SYN flood attack, but when I was doing a stealthier DOS attack, the IDS, the snort IDS that I used, it was not able to detect. Okay, so I developed this model over here, which was even able to detect this uh, stealthy attacks, right? So the code part of it, you can skip this because if you don't have knowledge of Python, you won't be able to understand this, but it is not uh, a big thing, right? Python can be learned easily within a matter of 1 week, right? You'll have enough knowledge that how to read this particular code and how to even use generative AI to assist you with this coding, right? So that can be taught. Like we have this AI powered security class also, so there you can learn how to develop and deploy these models. So here you can read these comments over here. That will, so these are all the Python libraries that we are importing, even the external library. This one gives you the data analysis properties. It will help us in the data engineering, pandas and numpys, right? This is our model decision tree model we are importing, right? From the scikit-learn is a library where we have machine learning models we can import. So this decision tree is a machine learning model, and even your random forest, which is a combination of many decision trees, right? And is our library for importing all the metric scores for if you want to calculate the accuracy, and if you want to see the false classification reports and confusion metrics, matrix, as you can see, it has four quadrants. Four quadrants will give us the value of false positive, false negative, true positive, and true negatives. Okay, and for visualizing our data, we can use this matplotlib. This is the library. Okay, so see, first of all, we are loading our normal and DOS related traffic data. Okay, so I have two data sets, normal one and multiple DOS. So if I just show this to you, right? So this is a data set here. This is my wireshark capture. Okay, so this entire process I can automate it using libraries like PyShark. I can even automate this into a pipeline that uh, run this program. I can create a cron job, you know, that it is a time based or event based. We can create that to run this program if this at this time, or run this program at this particular event, right? So that particular program will collect this data automatically, and then you can automate. I've automated this data collection process, and you can see our packet related data we are getting over here, right? Packet number, our timestamp, source IP, destination IP, protocol used. Okay, then your packet length, then source port, destination port, and other related information also we have. So this is our information for our normal network traffic. And this one that you see here is information for DOS related traffic, right? Because though it appears same, the column names appears same over here, because both are your Wireshark packet capture only. So this is our packet capture data that we have. Okay, so this was our packet capture data. We have uploaded it, and then we have combined it, right? You can give prompt also in generative AI tools. You can give a prompt that combine this over here, this data set, label your normal one as 0, DOS as 1, right? So these are the commands for labeling it. Then you have combined the data set and even shuffled it. You have concatenated it, right? So now, if you remember, so this was our feature, our pre-processing part, right? Converted into a structured data set. Now we have our rows and columns. But now what we are doing, we had one feature engineering phase also. If you see that, we had feature engineering. So what we, since this is a model for detecting DOS attacks, we are extracting those features. See, we are extracting those features that tell us what a DOS attack is. So see, we know that time difference between packets will be very less in case of DOS. So we are calculating time difference also. We have created a column here. So we are creating a new column which has time difference. We are creating a new column, packets per second. We are creating a new column that if we are getting consecutive UDPs over here, right? Or if that data, if your flags, TCP flags, if they have data associated with them, right, that is also a sign of DOS attacks over here, right? So we are teaching our algorithm to identify these patterns in the data. Okay, that is how it is able to identify the patterns, because we are telling it to identify these patterns, and then as we train it further, it will learn further, and with new incoming data, it will learn further on. Okay, so we will normalize the features, because we need to convert all the features, like the place values we have. We can have 10,000, 5,000, but we want to shorten them. We want to represent all our values between 0 and 1, right? So the shape of the graph, the data won't lose its shape and meaning, right? It will just be more condensed over here, right? So that way it will be more easier to compute. Our accuracy of our model will also go high. Okay, so now we have our model training phase, right? So we have all our features in our x variable. We have put features. Okay, time difference, packets per second, normalized, is UDP, TCP flags with data. Okay, and why, what we have given, we have given the label. Okay, and if you remember, I told you while explaining the model that you have features and you have labels. So while testing it, I told you, so while testing it, you're using this dot fit function over here. Okay, and you're fitting two things. You're training features and you're training labels. Okay, and while predicting it, we are giving it only one thing, the features. It has to predict the labels. Okay, and I told you, for calculating the accuracy, we will compare what, these two things, your actual labels with your predicted labels, right? That will give us the accuracy. So if you see, we are getting a very good accuracy of 99.5% over here. We have fine tuned this model, and this is a confusion matrix where we are telling, okay, actual here is normal, predicted or also normal. So 612, 612 true positive, true negatives. Okay, 587 true positives. Okay, predicted DOS, actual also DOS. And this over here is giving false positive, that act predicted was DOS but actually it was normal. And here this quadrant you can see that actual is DOS and predicted is normal. So here we have one false negative. Right. So this was our training phase. Then what we'll do to show you that it is working with completely new data, I have uploaded a new data set over here. And by the way, these are my models. This is in tree model.pkl, random forest model.pkl. So this is the model that I will integrate with sim tools also, or integrate it with EDR solutions. Okay. So now I have completely new data, DOS new data test.csv, which is just an Excel sheet that I'm uploading for newly collected data. Right. Then I've applied the same feature engineering tasks that which we had done earlier, right? No change in the code, just that same feature engineering task is there. And what we are doing, we are predicting it. So while predicting it, we don't have to use dot fit. We will use this dot predict method only, right? And give the new training data set that has come in over here, X new test, right? And then it will give the predictions. So you can see this decision tree model. So in both the models have predicted DOS attacks, right? This attack was the IDS was not able to integrate it and was not able to predict it, the rule based IDS. Okay, but this model is able to predict it. But you can see decision trees performance is not that good. It has predicted, it has got lots of false positives. But our random forest model, it is working very nicely. It has got very less false positives, right? Predicted class, you can see one is DOS, right? So it has found so many DOS data points in our data. Okay, this is how this model is working. And this is our end-to-end life cycle. Okay, so if you want to incorporate security into this, right? One second. See, we were discussing about explainability, right? So if you want your models to give but that if it is giving this particular result, why I'm getting that result, that you can get it through these frameworks such as Lime and Sharp. Okay, so this is actually I've put a data set over here which is actually used for cancer detection. Okay, so now after training the model, what we have seen different features such as worst area, worst concave point, worst perimeter. Okay, so I'm seeing that which feature is contributing most to my output. Okay, so if you're building your model for detecting phishing emails also, you can detect which feature is contributing most to that output, like whether it is that thing that IPL is used, the IP address is used, or a URL shortener is used. So all these things is can be more helpful when it comes to the auditing part of things, right? So this is our explainability part. Now this is also very important, robustness, right? So as I told you, there are three major adversarial attacks. When you talk about AI see, AI systems, you're using it as a security controls. So that is a new attack surface. So on these AI systems, you can perform adversarial attacks. Okay, and the main category of the adversarial attacks that we have, they can either be your evasion attacks. It can be both your data poisoning and model poisoning attacks. And it can be stealing the models itself, model theft, model extraction. These theft and extraction attacks are there. So what happens? You're looking at these things. You're looking at the evasion part of things, poisoning and theft extraction. So you can the attackers, they create such inputs, right? They will create such malicious inputs over here that will reduce the accuracy of AI models. Okay, it will reduce the accuracy of these AI models And how I will show you one demonstration again in this Google Colab only, that we have our cloud-based Jupyter notebook, right? Just a quick, this last thing I'll show you. Right, so I have created a small IDS over here, intrusion detection system, and using which I'm trying to bypass that. What I've done, I've created a code here that is actually working as a machine learning based detector. Okay, so this particular one I've used sequential. So I've used deep learning over here. Okay, and this Keras model is there. So I've created a deep learning model that is acting as a detector. Okay, so what I've done here, I'll just show you the direct result. Initially we are getting clean test accuracy before adversarial attack. So the accuracy of our model is 78.2%. But what I did one adversarial attack that is called as evasion attack. What that did, it reduced the accuracy of the model from 78% to 5.9%. Now, you know, if the accuracy of a model is only 5.9%, then even if you're sending a malicious input, it will not be able to detect it because the accuracy is so less. So how will it detect it as malicious, right? Or 90, 94 times out of 100, you won't be able to detect it only because the accuracy is only 6%, almost 6%. Okay, so see, adversarial test, so that I was able to do because there is this thing called as FGSM, fast gradient method. Okay, so using this FGSM over here, I was able to generate the adversarial examples using this. Okay, so what we need to do, if attackers are using these adversarial inputs, as in such malicious inputs, so we need to modify our training data. We need to include these malicious inputs also inside our training data. Okay, so that it can learn. So for this, we have different frameworks. We have frameworks like your adversarial robustness toolbox also, right? That is there by IBM. So you can see that here we have used a framework called as Clever Hands. Okay, so using this, what we are doing, since we are seeing that attackers can reduce the accuracy, so what we'll do, we will provide training to the model. Okay, so you can see clean test accuracy after adversarial training is 77.8%, right? Adversarial test accuracy after adversarial training. So what we did here, this is original accuracy 78%. This is after performing that attack, accuracy went down to 6%. Now you can see here original accuracy 78%, but after adversarial training, if we are doing the if attacker is doing adversarial attack, still our accuracy is not going down. Why? Because we have made our system more robust. We have provided it adversarial training, right? So second time you can see this accuracy of our model is not going down even if you're doing this attack. So that's why your responsible AI systems, they need to show this property of robustness. And how it is possible? By using frameworks such as this adversarial robustness toolbox or your Clever Hands. Okay, so you have seen that we through our GRC lens, if we see things that how this responsible AI should be fair, explainable, robust, privacy, safety. But now we have seen that technically also, that how you're actually deploying it, that properly how you need to deploy it, right? So same way, your data, like by performing prompt injection or adversarial attacks, it should not give out the sensitive data, right? You need to store them properly, right? People should not be able to steal your model, right? You need to secure the API endpoints. So all these security controls you need, and you need to deploy them such safely. You need to consider all the edge cases also, whether any harm can be caused to human beings, right? Societal harm, environmental harm, right? Physical harm, all these things need to be considered, right? So the safety is also another parameter that we have, right? Yeah, so we have our last slide here. So in the meantime, I will share my LinkedIn also. Yeah, yes. And see, this is just a reiteration of the thing that we covered here, that I showed you practically also. This particular diagram that you have here, these are your phases in machine learning operate, your ML ops phases that are there, your end-to-end machine learning life cycle. And this is Now considering all the security use cases also, all and every phase, what all security, what all things you need to add the security part in MLOps. Okay, so while you're collecting your data, see, data ingestion, data collection means collect logs, traffic alerts, right? You can perform data sanitization, access control, who has access to data, so that your data, the privacy aspects are maintained, right? We had seen one of the pillar of our responsible AI is privacy, right? Then we had seen feature engineering also is another phase that we have. So where we want to extract the relevant patterns, what we want to teach our algorithm to identify these patterns. Okay, so security considerations, you can detect the model drift over there, right? You can prevent feature leakage, right? That's again the privacy aspect. Model training, so what I told you, this adversarial training, this code what we saw just now, so that was happening in the code itself, right? We were making our models more robust, we were providing it adversarial trainings, we were adding that adversarial inputs into our data set. Okay, and then for fairness and bias also, we can use tools such as IBM's fairness 360, Google's what if tool, Microsoft has fair learn. So most of these are Python frameworks only, which you can use in our code, right? And then uh, you have your model validation, where you need to actually evaluate it. You call it validation also, or evaluation also, where you evaluate your model, evaluate the accuracies, false positives. Okay, so robustness technique. When I showed you the Lime and Sharp framework for explainability, so that will come under our model validation part only. So that we can include it in this step, the explainability part. Deployment, you need to secure your API endpoints, right? You need to encrypt your model, you need to sign your models, so that is there. While when you so just an example that if you integrate it with SAME and SOC tools. Okay, in monitoring, you need to, because with time the accuracy of these models may go down, so you need to monitor this too. Okay, so the security considerations are the alerting, incident response activities, okay, response and feedback. You need to ensure this. If this is a part of security also, that where all humans in the loop should be there, right? Audit logs should be maintained while monitoring, right? And this is the continuation of the same thing that you have seen, but the thing is, this is with the tool names also. So don't worry, I'll share this particular diagram, these infographics that you have, I'll be sharing it in my LinkedIn also, so you can connect with me in the LinkedIn. So these are the things that we have already discussed, these are just the names of some tools over here, right? So we have completed with our session here. Mostly this was the last thing only. So we can keep it till here. And meanwhile, you can see these tools also. So some of them I've already discussed, like this Sharp and Lime and this Clever Hands and adversarial robustness toolbox, right? For the things is when you're collecting your data. So how this IAM or this security policies, your IAM policies, you can apply here, right? These are some of the tools for that. Okay. API gateways, how you can use Flask API over there to properly deploy your models that you have created.